When we interact with applications, we are triggering US state transitions. In our work, we study the information leakage of only the US state without knowing the exact pixels. We find that this leakage requires no privilege and can serve as a powerful attack building block. Check out how we use it to steal the password. This logs the attack information. The attack app is tracking the US state in the background, otherwise it is hard to find the best attack timing. The attack app just hijacked the login US state, so the password is entered into the attack app. Scary, huh? This is enabled by a newly discovered shared memory side channel, which we found to be a general problem in nearly all popular operating systems. So, system designers, watch out US state leakage. For more details, come to our talk on Friday. Thank you.
In the past, people have shown that multi-tenancy and sharing that enables high utilization could also enable cross-VM side channels that leak secret information. A straightforward defense mechanism against these attacks is hard isolation, where one either partitions all the resources between tenants or control information leakage by resetting or adding noise to the shared state. All these solutions are expensive to adopt as they either require hardware changes or incur high overheads and so on. We present an alternative called soft isolation, where we promote risk-free sharing of the hardware that improves security and retain many desirable properties. We do this with a simple modification to the hypervisor CPU scheduler. We show that existing attacks no longer work in this new setting, and exhaustive experimentation revealed that the strong security property comes at zero performance cost.
Machine learning is a powerful tool to build different security defenses. However, it can be vulnerable to dedicated adversaries. What if the adversary are actually online human users? They are smart, adaptive, and there are lots of them. This is malicious crowdsourcing, where attackers pay a large group of internet users to participate spam campaigns. In this talk, we look at how to use machine learning to detect malicious crowdsourcing, and also look at detailed countermoves from adversaries and how effective they are. If you are interested in machine learning and how to break a machine learning system, welcome to the talk. It's the last talk today in crime and punishment session. See you there.
This talk is about amplification attacks, in which so-called amplifiers unwillingly participate in denial-of-service attacks by reflecting IP-spoofed traffic. In this work, we first fingerprint these amplifier servers to understand their nature and characteristics. Then, we aim to reduce the number of amplifiers by closing their amplification vulnerabilities. Third, we show how even connection-oriented protocols, namely TCP, can be abused for amplification attacks. Lastly, we propose a technique to remotely identify ISPs that allow for IP address spoofing. See the full talk on Wednesday at 2 p.m.
Domain parking services are legitimately incorporated companies who control a tremendous amount of web traffic. Primarily, they operate as middlemen, allowing owners of underdeveloped domains to monetize their web traffic through either online advertising networks or traffic systems. In this work, we investigate the legitimacy of their monetization operations by infiltrating the domain parking ecosystem. Through our infiltration, we verify and quantify a number of illicit monetization activities, such as click fraud, traffic spam, and traffic stealing, which affect both domain owners and advertisers. Additionally, we estimate the fraudulent revenue to be as high as 40% of the total revenue for some parking services. If you would like to find out more about this dark side of the domaining industry, come to our talk today.
Do you know the password patterns used by the biggest internet user group? If you want to guess them, how would you guess more? You have 100 million reasons to listen to our talk. The paper leveraged over 100 million real passwords created by Chinese-speaking and English-speaking users to tell you the answers. By leveraging our findings, we improved the guessing efficiency by over 30% for Chinese passwords. If you want to know more details, welcome to our presentation, 4 to 5 p.m. on Thursday. See you there.
You've probably heard that Tor is slow, and researchers have been busy asking why. There have been over a dozen publications in the last 2 years alone that attempt to improve Tor's performance. A critical missing piece to all of this work is a definitive answer to the question, where is Tor slow? Come to our presentation on Wednesday at 4, and we'll explain what happens when an application with thousands of simultaneously active sockets runs on a kernel that's optimized for only a handful. We performed a multifaceted congestion analysis of Tor in both the application and kernel layers to pinpoint the root cause of Tor's slowness. Then using this information, we designed an algorithm that communicates with the kernel to put it to work for Tor's benefit rather than to its detriment. We found that our algorithm does not reduce Tor's security. Our work provides the key to unlocking the full potential of other performance enhancements and a much faster Tor. See you Wednesday after the coffee break at 4.
Single sign-on services provide a popular and seemingly easy way for developers to add authentication and authorization to their applications. However, it turns out to be surprisingly difficult to implement it correctly, even when using the provided SDKs. Mistakes lead to serious vulnerabilities, including enabling impersonation attacks and leaking credentials. We tried to get our minions to click fast enough to test our sites, but after they rebelled, we developed SSO Scan to automate the checking. SSO Scan uses heuristics to automatically find and click the login button and complete the registration process for 2 test accounts. Then, it simulates an impersonation attack by replacing a real token with a forged one and detects if the login is successful. We used SSO Scan to check 18,000 websites and found around 20% of the 1,700 sites that integrate Facebook single sign-on have at least one vulnerability. SSO Scan is available as an open source service at ssoscan.org.
Secure computation allows two parties to evaluate a function without revealing the inputs to it. We did that in a mobile scenario with two smartphones where one of them optionally can hold a smart card. We demonstrate three applications which are typical in the mobile domain: finding shared contacts of the participants' address books, scheduling a meeting, and scheduling a meeting while also considering location information. All that in a privacy-preserving manner without leaking information except the final result of the computation. We implemented everything on Android smartphones and made use of a Java card smart card for pre-computations. Thereby we were able to achieve runtimes below 10 seconds for almost all protocols and input sizes, which is truly practical and is able to compete with implementations on desktop computers. If you want to find out how we actually did that, we invite you to join our talk on Friday at the after lunch break crypto session at 2 p.m.
Private set intersection allows two parties to identify the elements they have in common without revealing any element that is not in the intersection. Its application ranges from secure database join operations over common contact discovery to relationship path discovery in social networks. Existing private set intersection protocols are based on different cryptographic techniques such as public key cryptography, generic secure computation, or oblivious transfer. However, these protocols have mostly not been compared, and it is unknown which protocol performs best in a particular scenario. In this work, we optimize and implement the most promising private set intersection protocols, introduce a new protocol, and compare all on a fair and equal base. Most prominent, computing the intersection for 1 million element sets requires as little as 20 seconds. If you are interested, come to the last presentation of the after coffee break crypto session on Friday, just before lunch.
libfte is a library that aids engineers in deploying format-preserving and format-transforming encryption schemes. Format-preserving encryption means the input plaintext and output ciphertext share the same format. And this has a number of applications, including in-place encryption of credit card numbers in databases, or in-place encryption of web form fields in a web browser prior to submission to an untrusted third party. More recently, format-transforming encryption has been used for censorship circumvention and incorporated into tools such as Tor, Lantern, and uProxy. In this talk, I'll present our new FTE construction, which enables control of the input plaintext and output ciphertext format, new algorithmic advances that overcome limitations of prior works, as well as discuss the tools included with libfte that enable an engineer to both design and deploy FPE and FTE schemes for their applications.
Hello, my name is Andrei Kostin. I would like to invite you to the presentation of our paper titled A Large-Scale Analysis of the Security of Embedded Firmwares. Let me give you just a few reasons for you to attend our talk. 1. We present the first public large-scale collection and analysis of the embedded firmwares. Second, we detail our approach along with the challenges associated with such research. Third, we present general results and a few case studies, including about 13 vulnerabilities which affect hundreds of thousands of online devices. Last but not least, we are making some of the data and tools available to the research community and to the public through the firmware.re website. Thank you for your attention, and I hope to see you at our talk.
While using mobile apps, have you seen ads that display sexually suggestive content or ask you to fill up your personal information? I'm sure that you did, and that's not surprising. But how would you feel if your kids were exposed to such inappropriate ads? With Brahmastra, we tested 220 kids' apps and found that many displayed ads inappropriate for children. We also tested 200 apps with Facebook Connect and found that 13 popular apps were still vulnerable to the access token attack. Then how did we test these apps? We did not use free graduate students. Nope, we did not use random monkey testing either. We developed a tool called Brahmastra that leverages the structure of Android apps to improve test hit rates. Come find more about our Brahmastra testing tool. Our talk is in the last session on Friday.
Do you have a television?
Yes.
Do you connect it to the internet?
Yes.
Are you out of your mind?
Sir, yes, sir.
This is the amount of information in a 56-bit symmetric key. This is a memory system previously assumed to be incapable of storing crypto-length keys. We present a data encoding and storage scheme to store random crypto-length secrets into human brains. We limited failure rates to 12% for reads that followed 3 to 7 days of memory system idle time. However, failures increased when the system was idle for longer than the 2 weeks during which we had made use of it. So if talks about brains excite you, come to the last talk of the password session, just before Thursday's happy hour, and enjoy a talk that's guaranteed to both grow your mind and increase its nutritional value. See you then.
The idea for control flow integrity, or CFI, came about when I was involved with the creation of Windows XP Service Pack 2. At the time, attackers were executing bytes they found opportunistically in natural language localization data. And we quickly realized that even if we made that data non-executable, the attackers would just as easily use executable byte sequences they would then find elsewhere in the address space. So we defined control flow integrity as the safety property that execution always follows some control flow graph that's specified ahead of time. But unfortunately, CFI has never become a standard feature of production compilers, and implementations have struggled to support even common features such as dynamically linked libraries. Remedying this situation, our paper at this conference presents CFI implementations for GCC and LLVM that protect the forward edges of execution.
I'm Tao Wang, and I'm going to be talking about our paper, Effective Attacks and Provable Defenses for Website Fingerprinting. Anonymizing networks like Tor can protect your privacy on the web except against powerful global adversaries within international reach. But even local passive wiretappers and packet sniffers can compromise your privacy with website fingerprinting. All they need are packet times and packet directions. We will showcase a new attack using the k-nearest neighbors classifier that vastly expands the real attacker's capabilities, as well as being faster, more accurate, defense penetrating, noise resilient, and more. To protect users against this sort of attack, we need provably effective defenses against all possible attacks. We construct a class of such defenses and discuss how bandwidth optimality can be approximated and identified. Our results show that without using our defense, which has an overhead of around 70 to 90%, our attack can achieve 80% accuracy at only around the 0.1% false positive rate.
Recent research shows that it is possible to train humans in order to remember sufficiently long random passwords that can resist brute force guessing attacks. However, meet our attacker who is able to impersonate a legitimate website by fooling the user with an invalid certificate, compromising certificate authority, or even stealing the website's private key. The attacker can then mount a TLS man-in-the-middle attack, steal the user's password, impersonate the user, and gain access to his online account. TLS channel IDs and client authentication protocols built on top of them, such as Universal Second Factor by FIDO Alliance, attempt to address this problem, although as we will show, unsuccessfully. Instead, they actually need to be complemented by something more to effectively resist TLS man-in-the-middle attacks. Want to find out more? Join the last talk of the web security session on Thursday, just before the happy hour. That is all you need to remember.
Password managers make users' life easier by storing and autofilling their passwords for different websites. Secure passwords autofilling may look simple to implement, but there are a lot of corner cases. Let's take a look at some examples. If a user clicks through a SSL certificate warning to a login page, will it be safe to autofill the password? Or is it safe to autofill passwords in login pages inside iframes? What if the iframe is invisible? We find that existing password managers have inconsistent autofill policies for such corner cases. We show that autofill policies of most existing password managers allow network attackers, like an evil coffee shop owner, to remotely steal passwords. These attacks are completely automated and require no user interaction. If you're wondering how these attacks work and how to defend against them, attend our talk on Thursday at 2 p.m.
Gyroscopes are present in most of the modern smartphones. They measure angular velocity, and every application and website can access them without requiring the user's consent. We show that we can use gyroscopes to eavesdrop on speech without using the microphone at all, which can potentially risk private information such as identity, social security, and credit card numbers. Want to know how? Attend the Gyrophone talk.
Hello everybody, my name is Alexandros Kapravelos and I will be presenting our paper on Thursday titled HALK, Eliciting Malicious Behavior in Browser Extensions. So far, to compromise a user's computer, attackers relied on drive-by downloads. These are attacks that target the user's browser or its plugins, and after the exploitation, infect the machine with malware and make profit out of it. But what if I told you that you don't need to exploit the browser, and that there is malware written in JavaScript? In this work, we present HALK, a system that dynamically analyzes browser extensions to identify malicious ones. During our talk, you will find out what is a malicious browser extension and how powerful it is to run JavaScript inside the user's browser. There are several challenges in analyzing extensions, since they are dependent on the pages that the browser visits, If you want to learn how Hulk deals with these challenges, come to our talk at the web security session, The Browser Strikes Back, on Thursday at 4 p.m.
My name is Matt Fredrickson, and I'll introduce you to our paper on privacy in pharmacogenetics. In this paper, we show how certain types of privacy can lead to mortality and other negative outcomes in a clinical setting. To do so, we study the use of genetic information in warfarin dosing. Warfarin is a popular blood thinner used to prevent incidents of stroke. However, prescribing warfarin remains a challenge for doctors, where high doses can lead to bleeding. Low doses fail to treat the patient's original risk of stroke. New work has looked to using regression models that assign good doses based on a patient's genotype and their background. In this paper, we show that these models can allow one to predict a patient's genotype given their background and their warfarin dosage. We also find that differential privacy is able to prevent these attacks, but the budgets that do so can lead to worse dosages than the current clinical practice, and this in turn can lead to increased risk of stroke, bleeding, and mortality.
Hi, I'm Bimal from MPISWS. I'll be presenting our work on detecting anomalous user behavior in social networks. Most social networks today poll the wisdom or opinion of the crowd to rate or rank content. Unfortunately, there are several black market services available today to manipulate this crowd opinion, where attackers can manipulate content rating or artificially boost the popularity of a user. The challenge here is that today attackers use diverse attack strategies to carry out such attacks. In this work, we take a step towards using an unsupervised anomaly detection approach to identify misbehaving users on Facebook. Without learning about any specific attack strategy, we catch like spammers on Facebook who use fake accounts, compromised accounts, and even incentivized collusion networks. Lastly, we apply our approach to identify click spam on the Facebook advertising platform, where we get some very surprising results. To know more, please attend our session. Thank you.
Verifiable computation enables the clients to outsource computations to untrusted servers in the cloud while being able to verify the correctness of the result. Recent research showed the feasibility of doing this using a small constant size proof that's independent from the computation size while providing a short verification time. However, one challenge that remains is the proof computation time, which is highly correlated with the size of the computations to be done. For example, if we wish to perform a simple verifiable join query, we will easily see how the proof computation time increases rapidly with the size of the input sets due to the large circuit representation of such computations. In TrueSet, we propose a new construction to significantly reduce such overhead for set operations. We propose constant size circuits to verify the correctness of such operations, and we show how this improved the prover's time significantly. See you at the talk.
Come to the return-oriented programming talks, where we will discuss all things return-oriented programming. We will give you a complete introduction to return-oriented programming. We will survey the existing return-oriented programming defenses and discuss several in detail. And we will show you how to completely break them, hardening existing exploits to bypass these defenses. We hope you will join us and learn why ROP is still dangerous.
Automated dynamic malware analysis is widely used to combat new malware threats. This dynamic analysis system executes samples in a virtualized, emulated, or heavily instrumented execution environments. However, many recent malware samples try to evade such analysis by detecting the presence of such analysis environment itself and stopping their malicious actions. In this work, we present Bare Cloud, an automated evasive malware detection system based on bare metal dynamic analysis. That is, samples are executed in a real hardware with no emulation, no virtualization, and no in-guest monitoring component. This makes our system more transparent and robust against sophisticated evasion techniques such as timing attack. Bare Cloud simultaneously executes the same sample in 4 different environments, namely bare metal, Ether, Anubis, and VirtualBox, and compares its behaviors. We introduce a novel behavior comparison technique based on hierarchical similarity. If you're interested in the details and the results, please come to our talk at the forensic session on Thursday at 9 a.m.
Have you ever used IDA in your research? Do you need to identify where functions begin or end, or which bytes belong to which functions when you analyze binaries, especially strip ones? How much confidence do you have if you use IDA to answer these questions? Among those functions found by IDA, how many do you think are correct, and how many did IDA fail to discover? Besides IDA, how well do other function recovery techniques work when tested with thousands of real-world binaries? If you want to know the answer, join our talk at Friday morning, Program Analysis, Attack of the Code session. Check out our tool, Byteweight, Learning to Recognize Functions in Binary Code. Download our experiment and see for yourself how to take function identification into your hands.